Alright, so this is chapter 12, part 2 video, and we are looking to begin quadratic formula. And here we go. So the quadratic formula is looking at the equation. Let's go ahead and write that out. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So the first step is get it in standard form. So we have zeros equal to ax squared plus bx plus c. And then set this equal to 0 right here. So if I move this 3 over by subtracting, I'll have this. Minus 3, negative 12x, 3x squared. And yes, I have is equal to 0. And you can put the 0 on the right side, or you can put the 0 on the left side. From this, you get a is equal to 3, b is equal to negative 12, and c is equal to a negative 3. Otherwise, a, b, and c. Alright, so finishing this up, we have a negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And all I did was substitute the a's where they go, and the b's where they go, and the c's where they go. Alright, so now this negative times a negative is going to equal a positive. So we'll go ahead and just change that to a positive 12 right now. And then as you're doing the quadratic formula, guys, this right here is very important. A lot of people tend to struggle with this sometimes. So negative 12 squared gives you the 144. And you're going to do negative 4 times 3 times a negative 3. So negative times a negative will be a positive. These two are 9, and 4 would be a positive 36. So that's the square root. You have 12 plus or minus, and it's all over 6. Okay. So again, we're still going to add these two. Say again?
Wouldn't it be negative 6? So it's a negative 3.
Oh, it's actually it's 2a, so it's a positive 3 right here. And then 144 plus 36 is what? 180. 180. Yeah. So 180 square root 12 plus or minus and 6. And in case you don't know this, guys, this plus or minus, it's two answers. It's this one and this one. Okay? So now we just have to simplify. Okay? And there's a good chance that these will be on a non-calculator section. So you need to realize, how do you simplify? And these would be on the non-calculator, like the end of a non-calculator most likely. Okay? So one of the more difficult ones, because it takes so long to do this problem. So 180, if I'm going to simplify this, I need to start thinking about big numbers that can be divided into 180. Okay, big numbers. So like this. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, so on and so forth. And I want to see, can I divide 180 by these numbers right here? Okay, so the one that I see is 9. Okay, so I could break up 180 into 9 and 20. See how I did that? And then 20 I can even break up again using this one. So I can break up 20 into 4 and 5. So I have 9, 4, and 5 all underneath the square root for 180. Okay? What will this 9 come out as? A 3. What will this 4 come out as? A 2. And you're going to multiply those when they come out. Okay? So you will be left with, alright, so let's fix this up. You will be left with 6 root 5. You still have that 12 plus or minus, and it's over 6. And again, this right here is the same as having 2 of these, so that you have, 12 plus 6 root 5 over 6, and 12 minus 6 root 5 over 6. The 6's will cancel out. The reason why I wrote it this way is because I want you to see how in 5th grade you used to go the opposite. You would combine two fractions together. This, I want you to break them apart. Okay, so it's like seeing this right here as 12 over 6 plus 6 root 5 over 6. And this one as 12 over 6, because you have the common denominator and 6 root 5 over 6. So this common denominator will be here and here, and of course this common denominator will be here and here. Okay, just like you guys said, you're going to reduce this. You will reduce this to what? 2 plus root 5. Okay, so there's one of your answers. Okay, so x is equal to 2 plus root 5 is one of them, and this is 2 minus root 5.
It did a thing like where it was an I instead.
For this one,
Yeah, it was
Yeah,
increase with
you had to like
Oh,
change the root to
Yeah.
like an I instead.
I don't know if was it this one?
here's what I'll say. If it did, most likely where it would exist is when this right here, this piece, is a negative. So if it's a negative number, it will give you that. All right. Here's what I'll say. The I, a way that you can identify this again, because these are going to be non-calculator questions. The earliest that you can identify is with something I believe we might have talked about already. The discriminant test. Okay? That's only looking at b squared minus 4ac. Okay? What did we get when we did b squared minus 4ac? 180. And it was a positive 180. So guys, if you get a positive, so this one's going to either be a positive, 0, or negative. If it's a positive, you're going to have two answers. Okay, so you'll have two real solutions, otherwise two answers. If it's equal to 0, you're going to have one double root. And if it's negative, you will have two imaginary solutions. So what you guys were saying as far as you had the i's involved, that's when you are looking at imaginary solutions. Okay? And there's a good way to remember that those i's are when you're going to have the imaginary solution. Let me give you an example. Let's say that I have something that you should have definitely practiced over the last week was the difference of squares. Oops. So a difference of squares is basically they're the same thing, only one is a positive and one is a negative. Because when you multiply these out, you'll get x squared. You'll get the last terms are a negative 4. And then notice this, the inside term, which is a negative 2x, and the outside term, which is a positive 2x, they will basically cancel out to what? 0. So I'm left with a difference of squares. This is why we call this a difference of squares. We call it a difference because, of course, there's a subtraction that means difference. And these can be square rooted. This x squared broke up into two x's, and this 4 breaks up into two 2's. Okay, so going backwards is factoring, going forward is distribution multiplication with FOIL method. Otherwise, anyway, you get a x squared minus 4. Now, the reason why here there would exist two answers is because, look, if I looked at this one, all quadratics, when you solve them, fundamentally you want to set them equal to 0. Okay? So if I do that, and I move the 4 over, what's the answer? What squared would give you 4? 2 and negative 2, right? Positive and negative 2. That's where I get here a 2, and here I get a negative 2. Remember, each piece are set equal to 0 and you solve for x. Now, a difference of squares will work. Let me show you these imaginary eyes, where they come from, okay? And if you can see, the easier ones, the more difficult ones are faster and easier to go to. So this one was, if you notice, this was my equation. What would A equal? On this one right here, what would A equal in standard quadratic form? 1, yeah? So A is 1. What would B equal? 0, because there's no x term. And what would C equal?
Negative
-4.
4.
So if I follow this right here, primarily just the discriminant test, which is this piece right here, I could see that b squared, which is 0 squared, minus 4 times 1 times a -4, I'm going to get a positive answer. And if I get a positive answer, that means I will have two real answers, which are right here and right here. But if I get a negative answer, okay, let's change it up. Let's say that what if this was +4, so this was a +4, so it's minus 4ac. This would give me 0 minus 16. This would give me a negative, which would be 2 imaginary roots. Y'all follow? If not, you need to stop me, okay?
Yeah.
So 2 imaginary roots means when I solve them, watch what happens. It would be like me setting this piece equal to 0, okay? And then solving for x. So I'm going to move the 4 over by subtracting, and here's where the i's come into play. Okay, you ready? I'm going to take the square root of both sides. So the left side, what do I have? Just x. Okay? And the right side I have, what's the square root of -4? Well, I know that I can break this up like that. You with me? What's the square root of 4? 2. What's the square root of -1 come out as? Actually, the square root of -1 comes out as I. Okay? So, two things that you have to basically be familiar with is the square root of -1 is I. So if I squared both sides, I squared is -1.
So that's going to show up a lot on the
It will, and even on the ACT as well. Okay, they're just imaginary numbers, and here are the biggest things that if you can identify. First of all, you know you're going to work with i's when you try to take the square root of a negative number. Okay, listen, this is why. If you remember, it's been a while for some of you. Some of you, you probably recently did this. You have a function that looks like this. Y equals square root of x. This function fundamentally looks like this, guys. That's a function. I can take the square root of 4 and get what? 2. I can take the square root of 9 and get what? 3. You see what I'm doing right now? So, but I can't take the square root of negatives because there's nothing on the graph. It doesn't show up. And the reason why it doesn't show up is because these are imaginary numbers. And don't think like imaginary numbers like SpongeBob, imagination. None of that. It's not that kind of stuff. Imaginary numbers are still factorable, but they have this other feel to it for later on math. For right now, the only thing that I want you to concern yourself with when it comes to imaginary numbers are these two facts right here. The fact that the square root of a -1 is I, and that -1 is equal to I squared.
So you would put that next to the 2.
What would happen if you, if you took I and then,
I'm listening.
if you put like, I times say 4 and then cubed and then square rooted it?
I times 4,
Yes,
like 4I,
yes,
and then you cubed it,
yes,
and then square rooted it.
yes.
So let me get to that first, okay? Let me get to that in a minute. Let me finish this problem first, and then I'll go to that one, okay? because you can sometimes see stuff like that too. All right, so right here, you were just asking what would our answers be, right? So our answers, because of the fact that I took a square root, oops, I'm going to have a positive and a negative answer. Okay? That comes from that. The I comes from this negative 1 piece, like I showed you here. That's where I comes from. And then the 4 is just by itself, 2. And they will always come in pairs because my graph is quadratic. Okay, this is a huge unit. This is a big, if you can understand what I'm showing you right here, it connects with a lot of other things that you're going to have for the rest of the 5 weeks, okay? These will have 2 answers. I told you if that discriminant test came out to be a positive, you'd have 2 answers. It looks like this. It would cross the x-axis at 2 spots. If you had 1 double root, it would bounce off the x-axis because there's only 1 answer. Here, there's 2 answers. And 2 imaginary roots, the reason why we show that is that it still has a bend to it. It still has 2 answers, but they never cross the x-axis. So we call them the imaginary answers. Okay? If you had something that looked like this over here, so you had the square root of 4i raised to the 3rd power, most likely what you would see this as, you would just see it as fractional exponents. Okay?
Fractional exponents? What do you mean by that?
So check it out. You would see the square root is the same as raising something to the 1/2 power. Okay? So you would have 4i cubed, like this is what you're asking, right?
Yes, sir.
Okay. And then you would raise it to the 1/2 power. So all you're really going to be looking at is that this is going to be 4i to the 3/2.
What I mean is what would the calculator spit out from that?
It probably would just spit out exactly what you see. If you have something in that context, it's not looking at I per se. It's looking more so at the powers as far as what happens with the powers when you have a power raised to a power. If it was a calculator problem, you could just type it in. It would spit out your answer. You see what I'm saying?
Yeah.
We're looking at non-calculator content. Okay. What else?
So it was like the next couple of weeks just going to be non-calculator?
No, it's all mixed. Right now we're answering questions from the Delta Math, but also from chapter 12. Okay. All right. So.
I left my boat.
Okay. So. Right now, and it's asking us to factor this one, right? Okay. So guys, factoring this, I want to show you something real quick, and only on this first problem, to get your brain going as far as what's happening. You're going to see factor everywhere. Okay, you're going to see a lot of polynomials. You had homework with polynomials and rational functions where there's a lot of factoring everywhere, and you got to be good at it. What makes it difficult is a lot of people, they go to quadratic formula, and it takes forever to factor if you do quadratic formula. And all factoring is this. I want to first get this in quadratic standard form. Okay. So if I combine like terms and I move this 5 over by subtracting it, I will be left with just this. Okay. I don't want to go to quadratic formula firsthand. Okay. I want to see, since I have 2, as far as, I don't know why it's taking forever to highlight. There we go. As far as my power is concerned, then I will have 2 factors. Most likely, I will have 2 factors. What do you see right here that I said? It was 3 words that describe something that looks like this.
Imaginary and...
Not imaginary on this. It was a something of something else.
It would be x squared multiply, no, it would be like
Let me write it out.
That's what I meant. Like you would get the imaginary roots and then one root and then
Okay, so let's go ahead and work it out.
two positive roots.
So yeah, so this is a difference of squares, okay? First step, these two, and guys, this will work pretty much, I would say at least 90% of all factoring you can do with this. The first two will multiply to get my x squared. So here we go. X and x will multiply to get x squared. The second two will multiply to get my c term. This term right here, which in this case, and I'm going to color coordinate them so you can go back and see them in the video. So you have to tell me, for you to get good at this, your math from 3rd grade has to be on point. It has to be quick. What are the factors of 16? Well, in case it's been a while, watch. 1, 16, 2, 8. Can 3 multiply with something to give me 16?
No.
No. But then you have 4 and 4, right? So right now I have these factors that can multiply like a rainbow. 4 times 4, 2 times 8, 1 times 16 to get you what you want. And here's what I'll say. You always want to start at the center of the rainbow and work your way out. Okay, so let's start with 4. So I'm going to put 4 twice. 4s will either add to get 8, or they will subtract to get what? 0. And this right here that I'm doing is for b. I'm looking for that b value. In this equation, can you tell me what b is equal to? 0. So I chose wisely if I use these two 4s. So when I put them back into the equation, I will put 4 here and 4 here. And the last thing I need to do is just figure out what are the signs going to be. Are they both positive? Are they both negative?
One's negative, one's positive.
One's negative and one's positive. And there you go. These will be your factors that you can set each one equal to 0. Because look, if I set this equal to 0 and solve, I get a negative 4. If I set this equal to 0 and solve, I get a positive 4. Watch the highlight. This is the factor, but this is the solution, the answer, the 0, the x-intercept. This is the factor, but this is all that I just said. So if I were to graph this out, here we go. This negative 4 would be right here. This positive 4 would be over here. And because it's a positive x squared, this graph is looking up, going through both of those x-intercepts. Okay? So now let's do the more involved one, okay? Because they do get progressively more difficult, and you have to see, you gotta, I would say at least 10 to 20 examples for you to start to really understand it very well as far as what are quadratics all surrounding. So here we go. 5x minus 1 squared minus 24 is equal to 28. Okay? And we're trying to solve for x. What should I do to start getting x by itself?
Plus 24.
Plus
on both
24.
sides.
Yep. So if I add 24, I get 52 equals 2 times 5x minus 1. What's the next thing that I can start moving over there? Not distribute. Divide by 2. Okay? So this would give me a 26. This would give me 5x minus 1 squared. Any questions so far? Okay. So next, I'm going to take the square root of both sides. When I take the square root, this will cancel with that. So all I'm left with is that. Okay? And over here, when I take the square root, I need to remember that when I take the square root, there's a positive and a negative answer. So this will have two different answers. Okay? So this is like saying I have two equations right now. I have 5x minus 1 is equal to the positive square root of 26. And I also have 5x minus 1 is equal to the negative square root of 26. Now we've been talking square roots. We've also been talking with negatives. Will this produce an I?
Probably.
It won't, because I'm not taking the square root of a negative. The negative is on the outside. That's okay. Okay? So now, from here, all I have to do to get x by itself is what? What do I do? What do I start moving over there to get x by itself? Plus 1, and then what? Divide by 5. So x will be the square, or 1, plus this positive 26 divided by 5. There's one of your roots. The other one, I'm going to add 1. So I'm going to do positive 1 plus what's already over there, negative root 26. It's still divided by 5, and I'll get x. So guys, you can use quadratic formula. But to me, I think that's way too much, because then you have to actually distribute this out to use quadratic formula, and it's just too much. It's easier just to remember. The big thing on all of this is to remember that you have a plus or minus whenever you take the square root. Okay? Questions? Okay. Let's see. What other one? Go ahead and find another one. Alright, so you will see these most likely in non-calculator parts. And what it's asking you to do is simplify the square root. Okay? So the way we simplify is the following. First of all, we're going to try to break up 12 in numbers that we can actually take the square root of. Remember, square
Sorry,
root.
You're making eye contact again.
Okay. So square root would be 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, so on and so forth. I want to start with these numbers right here. This is what I want to try to divide by. Okay? So can we divide what's inside the square root by any one of these? The 4, yeah, the 4. I can divide by 4. So I will take, and I'm going to concentrate on this 12 right here, and I'm going to break it up into this. So that everything else is right here. Okay? What does the 4 come out as? Come on guys, don't be afraid to make a mistake. What does the square root of 4 come out as?
2 times 2.
2, right? So 2 will come out and multiply with this 8 to give me 16 y squared, and then everything else stays inside. Okay, so it'll be to the 7th, and then to the 5th. Okay, so it was just said just now that 4 will come out as 2 because 4 is actually camouflaged, if you will, as a pair, which is 2 times 2. You with me? And each pair will come out as what? Just one of those numbers. You with me? So let's say that I had, over here, let's say that I had 3 times 3 times 3 times 3 times 3. And I wanted to square root that. This right here would come out as what? That's 3. That's 3 just by itself. Okay? This one right here will come out as what? 3 by itself. So that one that's all by itself that doesn't have a pair is not coming out as anything. So I'll be left with 9 root 3. Okay, so visualize this. This x to the 7th is like actually having 7 x's lined up right next to each other. So when you square root them, they're going to come, and this 2 is an understood. I don't need that 2 there. but it's there for square root. How many would come out? How many of these would come out?
6.
6. But this one would come out as x. This one would come out as another one. So I would have 3 x's that came out, and your answer would look like that. Does it make sense?
Yes, sir.
So over here, 3 of them are going to come out. 1 stays in. So we have 3x. 3 come out. And I'm doing this by steps because I don't want you to get confused. And now let's break down this 5. How many come out? 2 of them. So if 2 come out, okay, how many stay in? Just 1. So I have 16x cubed that was already out there, y squared that was already out there. What do those y's end up becoming whenever you put them together? 4. Because you add those numbers, right? So if you need to scratch work, this is the same as adding. Okay? So it'd be like 2 plus 2. Notice the difference between when you're adding versus a power raised to a power. This is 2 times 2. Okay, so let's come back over here. My final answer is going to be 16x cubed, y to the 4th, root 3xy. Okay, questions? Okay, find another one. Okay, so this is an example from the end of chapter 12. It's number 11 on the drills part. And what we're trying to do is find if I is the square root of -1, what is the product of this guy and this guy right here? What does product mean? Multiply them. So we're going to FOIL. So we have 4 plus 7i is going to be multiplied with 1/2 minus 2i. Again, this will most likely be in a non-calculator portion. Otherwise, you could just put that in the calculator and it'd spit out the answer. Okay, so let's FOIL this out. So 4 times 1/2? 2. And then the outside, what does that give me? -8i, good. And then let's go with the inside, what do I get? Remember, you're multiplying these. 7/2 I, yep. And then last but not least, the last terms, when you multiply, what do you get? -14i squared, because it's I times I. Okay? Remember I told you, this will sometimes be given to you, should be memorized. What was I squared equal to that I told you? -1. And guys, this is the one that I memorized right here. Because how can something squared be a negative? It just goes against nature, right? And that's why this is like the intro into imaginary numbers, but you can go back and forth interchangeably. I just think this one's easier for me, at least, to memorize. So I know, and this is the one that they use on tests, I know that this is -1. So it's not really subtracting 14, it's subtracting 14 times the -1. So what are you really doing with this 14? Adding, yeah, because you're going to be multiplying by this -1. So it's like adding 14 to all of this mess right here. Oops, 14. So you have 2 and 14 to give you a 16. And now, you're just going to combine like terms. You're going to combine the i's together because they're the same term. And you're going to combine those two right there. So you just got to figure out a way of getting a -8 to add with 7/2 by hand without the calculator.
3.5.
Close. So let's do this with fractions.
Do you want them to be fractions?
Yep.
Okay, it would be 8 times 2.
Yep, so negative 16 over 2 plus 7 over 2. Negative 9 over 2, right? So this will give you a negative 9 halves I, and the 16 just comes right down. And you get A. Okay? Real quick, look through those couple of pages right there at the end of the chapter, and if other ones look familiar, like you'd want to work out similar to what we're doing right now, please tell me which one. Alright, so number 14 is also with the quadratic equation, but this time they're just trying to make it difficult by putting all these letters there. Okay, and don't let them throw you off with those letters. The biggest things to recognize is when you're looking at the quadratic equation, you're looking for an A term, okay, a B term, and a C term. So it'll look something like this. So you're looking for an A term, and a B term, and a C term. Okay? What do I need to do with what they gave me first? Equal it to 0. I can move everything to the left, or I can move everything to the right. To me, it's easiest when you get this as a positive. Okay? So instead of moving it to the right, I'm going to move everything to the left. So that R stays a positive R. You see what I'm saying with that? Otherwise, you have to subtract the R squared. So here we go. We will have Rx squared minus 1 over S squared minus 3, and we have it equal to 0 on the other side. Okay, and now we're just going to plug it in where we see the quadratic formula. So here we go. X equals negative b plus or minus, and b is negative 1/5, so, or 1s, that is. That's an s. Okay, it looks like 5, but it's an s. So negative b plus or minus the square root of b squared, need those parentheses, 4ac. So b is negative 1 over s. What's a? Come on, guys. What's a? Not 1. What's the coefficient of r squared? Or no, not r squared. I just kind of told you. X squared. Just r. So a is r. You with me? So this right here is the a term.
How did you get that? Like, is it that it's just...
It's just the number in front. So whatever letter or number or value that's in front of the x squared, that's what you're looking for.
So it's not 1. It would be...
It's not 1. It would be r on this. Most of the time they have numbers, like 1, 3, whatever they have. But this one they're trying to throw you off just to see, do you know where the placement goes? You know what I mean? So think of them as numbers, but you're just trying to put them in places. Okay? So again, this b is right here. And everywhere in the quadratic formula where b goes is where I'm putting all these numbers. Okay, and I'll write real quick. It's x equals negative b, whoops, plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we have our b terms in orange. We have our a terms in blue. And this is all over 2a, which is 2r. Okay? And then last but not least, we have the c term, which is what? Negative 3. Hopefully the color coordinating helps with you guys. Okay? And again, the discriminant test, it's all about this b squared minus 4ac. I would immediately gravitate to this piece right here and try to see if you can find it in one of your answer choices over here. Okay? So this right here of negative 4r and negative 3, what do all those multiply to?
Positive 12.
Positive 12r. So I see a positive here That's the only one that I see. You see what I'm doing?
Yes,
So-
sir.
So this would be your answer here.
Can I ask a bit of a question?
Yeah.
That I just thought of.
Yeah.
It's probably a really quick one.
Go for it.
So, will there ever be anything as complicated as like, up to the cubic for the, for what's it called, not a discriminant test or different squares,
Oh.
but that other one, 4x cubed plus say 6x squared plus 8x or whatnot.
To what? Factor?
Yeah,
Yeah.
like just a factor.
Yeah. And
There, you will get things that complicated plus like 16.
plus 16? Yeah. These are good numbers. This is a good example. Nice job. So looking at this
These
guy.
are just things I thought of on the fly.
That's all
It's
good.
almost time for me to go. It's 3 minutes.
No worries. Look, so first of all, what you would do is when you factor, the very first thing that you want to do to factor is GCF, greatest common factor. The greatest common factor over here that belongs on all of these is actually going to be what number? What
Two.
number? 2. And do they all have an X?
No.
No. The 16 does not have an X. So what you would do is you can pull out a 2 from all of these, and what you're trying to factor is 2x cubed plus 3x squared plus 4x plus 8. Do you see what we're doing? Okay. Now this is rare. These are the very hard ones on the non-calculator. This is rare, but it does sometimes happen. If I'm wanting to factor things that have 4 units, 4
Will
monomials.
you ever have something that has 8 units?
No. Well, you could just divide into 2 sets of 4. If you have 4, you're going to group them together. Watch this, okay? So what we're going to do is we're going to group these first 2 together and these last 2 together. Okay? Yeah, that's weird, isn't it? So these 4 I'm going to group, right, as far as 2 go. And the first 2 are 2x cubed plus 3x squared. All you're going to do, guys, is GCF again. Okay, so let's look at this real quick.
So that would be like x, wouldn't it?
X squared, right?
Yeah, x squared.
Okay, so you could bring this out as x squared. And what will be left here is going to be 2x plus 3. Okay, all I did was this, a GCF. This 2 that's way out in front, it's still over here. Okay, it's multiplying all of this stuff. And then this last one that you can pull out would be like 2. And if you can pull out a 2, you would have 2x plus 4 left.
That actually makes quite a bit of sense.
Yeah. And now, he was close. Like, he just created this on the fly. Now look, when you do these with problems that are built this way, these will be the same thing. If they're different, then you did some kind of factoring wrong. Okay, but he just created this out of thin air. It would be numbers that would work out. So it could work out like, let's just change it right here. Let's say they worked out to 2x plus 3 on both of them. What's in the parentheses is one of the factors. And what's outside of the parentheses, so let me color coordinate this. What's in parentheses is one of your factors. What's outside of the parentheses is the other factor. Okay? So in this case, it would be x squared plus 2. Whoops. And then finally, that 2 would lie out in front. So yes, if you ever have 4, they will group to 2 pairs of 2 with the GCF. Okay, sometimes we do have 3, and we'll make them into 4 and then do that. Or we can just factor the way that I was trying to show you earlier on today.
Did I have a very good question?
Yeah, that's a good question. Nice job.
Thank you.
Alright, so our last one, what it looks like is this rational function, fractions basically, and we're trying to find x. So when you have, and we learned this from geometry with proportions, when you have a fraction equals a fraction, I'd say 9 out of 10 times the easiest way is just to cross multiply. Okay? So we're going to do 2x times x plus 2 is equal to 2 times x squared plus 1. Now, the way I have it written right now, something's wrong. Like they're both equivalent as far as how you're cross multiplying, but can you tell me what I'm missing? Parentheses. I'm missing parentheses here, and I'm missing parentheses here, which are very, very important because we're not going to distribute this 2x on both if we don't write parentheses. Okay? So let's go ahead and distribute, and you tell me, what do I write on the left side? 2x squared plus what? 4x. Nicely done. And then what do I write on the right side? Yep. Plus what? Or just plus 2, right? Okay. So now we're going to get all what? X's on one side and set it equal to what? 0. So what do y'all want to do? Right or left side? It doesn't matter. The left. So let's subtract 2x from both sides. Or 2x squared, that is. Those are gone. Okay? So all I now have is 4x is 2. So x will be 2/4 or 1/2. You see it? So definitely cross multiplication on that. Simplification after that. Yeah. Okay, yeah, that one's a good one too. This one is solving a circle with a line, I believe. Yes. So y minus 4 is squared is equal to 10, and it's x squared plus this. And the other one is negative 3x plus y is equal to what? 4. Guys, this is a little bit different. Just a little bit different from all the ones that we've done on this video. Can you tell me what's different about it? I have 2 equations, and I'm going to have 2 variables. So a solution is not going to be like x equals something and x equals something else. A solution with this system of equations is going to be like a point. This is the solution. Okay? Here we go. My goal is to get these 2 variables to be 1. How can I do that? First of all, systems of equations. We've done this. I can find a common letter, or a common variable, right? So here we go, watch. I'm going to find a way to either make this into a y so that I have nothing but y's. Okay? Or I'm going to find a way to make this into an x so that I have nothing but x's. Okay? What do y'all think is the easier one to do? From what we're given. Okay, y is equal to 3x plus 4. What he did was he added the 3x over here. Okay, and now I can use all of this, which is y, and I can put it right here. Okay, so I did that with the second equation, and I'm going to use substitution to plug this in to my first equation. It's a lot of work, yeah. X squared plus all of this minus 4 squared equals 10. And remember, where y is at, I'm plugging in 3x plus 4. You got 100 on the homework, right? You finished it? Okay. No worries. Nice job. So 3x plus 4 minus 4. The inside would simplify to what? Anyone? 3x, yeah. So you have x squared plus the simplified 3x squared equals 10. What does 3x quantity squared equal? What will this equal whenever I simplify it? What do y'all think?
Oh wait, no, not
No worries. 9x squared, right? So 3x squared, I know it's a little looks simple, but it's actually a little involved, is the same as this. Because it's just two of them, right? Just like x squared is the same as that. So what do I get when I multiply?
9x squared.
It's 9x squared. So I have x squared plus 9x squared is equal to 10, which is what? What do I do next? Add them. So I have 1x squareds plus 9 more x squareds,
10x squared.
10x squared. Now what? Divide by, right? Divide by 10. Be careful. Come on, think about what we learned all day today. What are the answers? X is, don't be afraid though to make a mistake, guys. Come on. Negative and positive 1. Because when you take the square root, you have the plus and minus. Woo! It was a doozy. If you did not finish the homework, please go finish the homework. Okay, I'm going to give you some more, but you have to finish this homework because it's so connected to everything else that you will do forever. Okay, on this test that you're going to take in 3 weeks or whenever it is, to what's coming in Algebra 2, if you're not already there, what's in Pre-Cal. It's very, very important, this unit, for sure. I can't even stress it enough. Alright, guys, so I will assign Chapter 13 is due for homework next time I see you with drills. It's a short chapter, and I will also put some more homework on the Delta Math. Please, please come ready.